Hello. Here's what's inside the Indramat software module. Now right here is the Atmel AT28C64. That's the IC that we're going to pull the parameters out of. We're going to be able to read and write to that E-square prom with our programming adapter. Now these two ICs are 74HCT245 bi-directional octal buffers. They're attached to the data bus of the E-square prom and these EPROMs over here. This is the low side data bus. We have a low byte and a high byte, 8 bits each. The AT28C64 resides on the low byte side. There's two EPROMs over here that reside on the low byte side, and there's two EPROMs that reside on the high byte side. And this 74HCT245 controls the direction of the data to the high byte side. Here's the connector that connects to our programming adapter. Now let's go look at my drawings. You'll get a kick out of this. Alright, I'll be back in a little bit when I get my drawings up there. Give me a little bit. Now we're inside the Indramat software module. Here's the AT28C64-15SC. Here's the address bus. Here's the data bus. Here's the XP1 connector. That's that connector that we have to mate the Indramat software module to our programming adapter. Now, down here is the 74HCT245. That's our bi-directional octal buffer. Let's get close to the address bus and then we'll look at the data bus. We want to see the pins that, for instance, A12 mates to XP1 13B row. Here's the pin numbers for the address bus. There's A0 to A12. A0 is on pin 10. A1 is on 9. A2 is on 8. A3 is on pin 7. Address 4 is on 6. Address 5 is on 5. Address 6 is on 4. Address 7 is on 3. Address 8 is on 25. I like the way they bounce around like that. Address 9 is on 24. Address 10 is on 21. Address 11 is on 23. And address 12 is on 2. I've always wondered why they bounce around like that. Why can't they all just evenly come out the way they're supposed to? I would have put address 12 on pin 12. Now over here, address 12 connects to 13B. Address 11 on 12B. Address 10 is on 11B. And address, where are we at? Address 9 is on 10B. Address 8 is on 9B. Address 7, 8B. Address 6 is on 7B. Address 5 is on 6B. Address 4 is on 5B. Address 3 is on 4B. Address 2 is on 3B. Address 1 is on 2B. And address 0 is on 1B. That's the middle row of that 3-row connector. Let's go down and we'll look at the data bus. Here's the data bus. We have a 74HCT245. Now it's bi-directional, and I'll show you the control pins on that IC that determine the direction here in a little bit. But you can pull up a data sheet and see how it works. It's a fascinating IC to study. Data bit 0 to data bit 7, there's 8 data bits on that E square prom. Data bit 0 is on 11, data bit 1 on 12. Now here's how it should be. Data bit 2 is on 13, 14 is ground, so we have to skip around to the other side. Data bit 3 is 15, data bit 4 16, data bit 5 17, data bit 6 is 18, and data bit 7 is 19. Now, it attaches to the bidirectional octal buffer. The input and output is bidirectional. So data bit 7 goes to 8C, data bit 6 goes to 7C on that 3-row connector, data bit 5 goes to 6C, data bit 4 goes to 5C, data bit 3 goes to 4C, data bit 2 goes to 3C, data bit 1 goes to 2C, data bit 0 goes to 1C. Isn't that amazing? Now when we're writing to the IC, data flows from the B side to the A side. It goes in this direction, going that way. When we're reading from the E square prom, data flows from the A side to the B side, and we're going this way. Those folks is pretty smart who invent this stuff. Make these ICs. Okay, take a screenshot of that one so you can understand what's going on. We'll get to the programming adapter in a minute, but we want to look at the inside of this Indramat software module so we understand what we're doing with the programming adapter, why we need to build it in such a way. That's why we're looking at the insides of this Indramat software module. We'll get to the good stuff in a little bit, but we got to get the theory out of the way first. Okay, let me put up some more pieces of paper that we can look at. Now here on the 2-each 74ACT245s, we have 2 control pins. Pin 1 is the data direction, whether data flows from the A side, the 8 bits of the A side, to the 8 bits of the B side, or whether we have data flow from the 8 bits of the B side to the A side. Shoo! That's a tongue twister. So when pin 1 is high, data flows from A to B, the A side to the B side. When pin 1 is low, data flows from the B side to the A side. And that control pin, the data direction, is attached to that 3-row connector on pin 7A. Now we have an output enable. Data does not flow if pin 19 is high. You see this bar over that output enable symbol right there? That means that it's active low. That pin has to be low for data to flow in either direction. If pin 19 is high, the outputs are placed in tri-state. Now, pin 19 is attached to pin 1A on that 3-row connector of the Indramat software module. One more sheet of what's inside this Indramat software module. So be patient, folks. Be patient. Now here is the write enable. This is read write. It's read when it's high, write when it's low. Here's the output enable, and here's the chip enable of the AT28C64. Now down here are the output enables and enables of the EEPROMs, and we're not worried about that. So we're going to get closer to this circuit up here and see what's going on there. So you can take a screenshot of what's inside that Indramat software module. Now the right enable of the AT28C64 is on pin 27. And here we have a 22 kilo ohm pull-up resistor to 5 volts, and it is attached to pin 5A of that 3-row connector. The output enable of that IC is attached to 6A, and chip enable is attached to 4A. Now that's everything we need to know to build our adapter. I've got to hurry up, we're running out of daylight here. This is a long day's worth of work here on a Saturday. Had to go in, I was working on a Yaskawa transistor inverter drive. I'll have to make a video on that so you can see how to test it. Move this just over a little bit so we can get centered. Now probably the most ignored circuit when you're designing things is the power supply. But I believe that to be extremely important, because without the power supply, we're not bringing anything up. Okay, we're looking at the Indramat software module programming adapter right now. This is what you're going to build. Here's the connector where we bring our DC voltage in. We have an L78S05 CV, and you can use any 7805 in the TO220 package. We bring 8 to 10 volts thereabouts into this voltage regulator. It's filtered by this 470 microfarad 35 volt DC capacitor right here. The output of the 7805 is 5 volts, and it's further filtered on the output side by that 47 microfarad 16 volt capacitor, and it's going to go into the Indramat software module on pin 13A. Now inside the module, 13A and 14A are tied together, so I'm just bringing it into one pin, 13A right there. 16A is ground. All of these points right here are tied together, and ground is on 16A, and that'll power up that cartridge. Now you're probably wondering, why do we have to power up the cartridge? Doesn't the programmer power up the cartridge? Yes, it does, but it only powers it up for the duration that it's either reading or writing to that device. And we need to bring the Indramat software module powered up much longer than that programmer wants to power up that device. If we don't bring it up before the programmer goes and reads and writes to that EEPROM, it doesn't come up long enough for data to flow through or into and out of the 74HCT245 and eventually to the EEPROM. So this is why we have to power up that Indramat software module with our own power supply, and don't even use the one from the programmer. Use this one. Don't connect pin 28 of the programmer to pin 28 of the EEPROM. That's what I'm trying to say. It won't work. Okay, let's go up and we'll look at the write enable, output enable, and chip enable of the EEPROM to the programmer. Now we're looking at, again, the programming adapter. And here for the first time we finally made it here. Here's the 28-pin wire wrap socket. And it replicates the, if you pull up the data sheet, pin 20 on that E-square prom is the chip enable. Pin 27 is the write enable. Pin 22 on the E-square prom is the output enable. We have to do that so it properly gets plugged into and connected to the programmer. Up here are the 2H74 HCT245s, and here we are. This is our connector, our 3-row connector on our programming adapter. We want to tie pin 1A to ground, and that will output enable the 2H74 HCT245s. They will always be output enabled. They will never go into tri-state because we have grounded those output enable inputs. Here are the EEPROMs. We don't want to activate those EEPROMs. We don't want the output enables to go active because that would interfere with the data input and output of the E-square prom. So we tie the output enables of those 4 EEPROMs up to 5 volts, and they will always be in tri-state. Pin 20 of the 28-pin wire wrap IC socket has to go to 4A on that 3-row connector. 4A connects to the E-square prom chip enable. 27, let me skip 27 because we're going to get a little deep on 27. 22 goes to 6A, which is the output enable on the E-square prom. We want the programmer to control the chip enables and the output enables of the E-square prom. Now 27, it's called write enable. That's simple enough. But it must also control the data direction of the 74 HCT245. So I tied 7A to 5A and 5A to 27 of the wire wrap socket. So when we're writing to the E-square prom, the B side, the direction, remember we talked about the direction, the B side is low, so, oh, I'm scooched out of the way there. So data flows from the programmer into the EEPROM, the E-square prom. And when we're reading, 27 is high, we're in read, and data flows from the A side, the E-square prom side, to the B side, the connector side, back to the programmer. So that's why I had to, and this took a little bit of figuring out. The first time I tried this programming adapter, it didn't work until I figured out I had to control A and B with the right read-write signal. So don't forget that. 7A to 5A, 5A to 27 on the wire wrap socket. And that takes care of that sheet. People, how many more sheets you got to go? It's bedtime. We got to get up and go to work tomorrow. Hurry up. Okay, I'm trying. But doggone. You know, this didn't happen in a day. So talking about it takes a little bit longer than 5 minutes. Okay. All right. Hold on. We're almost there. Now, if you pull up the data sheet on the 28C64 E-square prom, pin 10, 9, 8, 7, 6, 5, 4, 3, 25, 24, 21, 23, and 2 are the addressing pins. Here's A0 through A12 addresses on that E-square prom. So tie pin 10 to row 1B, pin 9 on the 28 pin wire wrap IC socket. Remember, this is replacing the E-square prom on that programmer. So this is pin for pin, the pins of the addresses for the E-square prom. Tie pin 10 to 1B, pin 9 to 2B. This is the 3-row connector on our programming adapter. Pin 8 to 3B, pin 7 to 4B, pin 6 of the wire wrap IC socket to 5B, pin 5 goes to 6B, pin 4 goes to 7B, pin 3 goes to 8B, 25 goes to 9B, 24 goes to 10B, 21 goes to 11B, 23 goes to 12B, and 2 on the 28 pin wire wrap socket goes to 13B. And these will attach to the E-square prom inside the Indramat software module. Take a screenshot of that, and remember, now we're looking at the programming adapter. There's the data bus. We're on a downhill slope now. We're almost there. The next sheet of paper will be the chart that I used to wire wrap the connector, the 3-row connector, to the wire wrap socket. Now, here's the 28 pin wire wrap IC socket, and if you were to pull up a data sheet, you would see that 11, 12, 13 is data bit 0, data bit 1, data bit 2, 15 is data bit 3, 16, 17, 18, and 19 are data bit 4, 5, 6, and 7. Now they attach to our 3-row connector. Pin 11 of the wire wrap socket goes to 1C. Pin 12 goes to 2C. Pin 13 goes to 3C. 14 goes to 4C. Oh, sorry, 14 is ground. 15 goes to 4C. 16 goes to 5C, 17 goes to 6C, 18 goes to 7C, 19 goes to 8C. And that will connect the programmer to the Indramat software module, data bus, the low side data bus, where the E-square prom resides. Isn't that fascinating? You can take something apart and construct something up around what you took apart. Okay, all right, let's look at the chart. Now here's row A. I got my chart separated into row A, row B, and row C of that 3-row connector. Now we're turned sideways because there's no way I could get all this into the view of the movie camera without going sideways. Now here we've already talked about all of these connections, but I want to make a note down here on row A. Here's the 74 HCT 245 IC9 and IC10 inside that Indramat software module. It's the output enable. I got a note down here that says tie that low. Then here's the 4 EPROMs, IC1, IC2, IC7, and IC8. I got a note down here that says tie them high. So tie this pin 1A to ground, 2A and 3A to plus 5 volts. Here's a note down here on 7A. That's your data direction of the 74 ACT 245 pin 7A. I got jump to 5A. So connect 7A to 5A. Here's our 5 volts into the Indramat software module on 13A and 14A, but we're only going into 13A. Here's our ground on 16A. Let's go look at the address bus, row B. There's the address bus. This is the wire wrap socket, and here is the 3-row connector. Next, the data bus. Here's the data bus for the E-square prom. There's the 3-row connector, and here's the wire wrap socket. Alright folks, if you ever have a need for reading and writing to the E-square prom inside the Indramat software module, put this together. You'll have a lot of fun with this. It's a lot of fun learning things like this. Study how it was done, study why it was done, and study the putting together. Alright folks, thank you very much for stopping by and seeing what I'm experimenting with today. We'll see you next time. Enjoy the time with your family. Good night.